Well, hello and welcome back to the day two of Advent of Code 2024. We did a video just a few hours back and I've created a playlist. So if you haven't seen it, make sure to check that out. And let's begin discussing the problem of the day two. It's red-nosed reports. So, fortunately, the first location the historians want to search isn't a long walk from the chief historian's office. While the red-nosed reindeer nuclear fusion fission plant appears to contain no signs of the chief historian, the engineers there run up to you as soon as they see you. Apparently, they still talk about the time Rudolph was saved through molecular synthesis from a single electron. I'm pretty sure this is a reference to the last advent of code. So they are quick to add that since you're already here, they would really appreciate your help in analyzing some of the unusual data from the red-nosed reactor. So you turn to check if the historians are waiting for you, but they seem to have divided into the groups that are currently searching every corner of the facility. You offer to help with the unusual data, and the unusual data, that is basically our puzzle input, it consists of many reports and one report per line, and each report is a list of number called levels that are separated by spaces. For example, so we have a report given here. So let's get this into our playground. I will use the text and let's increase the size, make it so that it's easy to read for us, and let's make it a little bigger. Perfect. So looking at this puzzle, this example data, it contains 6 reports. So we can see 1, 2, 3, 4, 5, 6 reports are there. And there are levels. So this example data contains 6 reports and each contains 5 levels. So we basically have reports here and we have levels here. So a total of 1, 2, 3, 4, 5 levels, and 1, 2, 3, 4, 5, 6 reports. It looks like a matrix. So the engineers are trying to figure out which reports are safe. The red-nosed reactor safety systems can only tolerate levels that are either gradually increasing or gradually decreasing. So a report only counts as safe if both of the following are true. Okay, so we need to do some kind of a validation on this report. And the goal is to find what are the reports that are safe and what are the reports that are not safe. And what is the criteria? The criteria is that it is only going to be safe if both of the following are true. So we have 2 conditions where it says that either a level should be completely increasing or a completely decreasing, all increasing or all decreasing. And the second one says that any 2 adjacent level should differ by at least 1 or at most 3. So it should be at least the delta should be 1 or at most equal to 3. So let's look at that. In the given example, we can start to look at the first one. So it seems like that this is in a, that this one is in a decreasing order, because if you see from here 7, 6, 4, 2, 1, they're all decreasing. The second one, while it says it is 1, 2, 7, 8, 9, they are, but it is considered unsafe because 2 to 7 is increased by 5, which is not allowed. So it should be like between 1 and 3. So let's look at this 9, 7, 6, 2, 1. Again, this seems unsafe because this has a delta of 4. So this won't work, this won't work. 1, 3, this doesn't work because this was increasing and now it is decreasing. 8, 6, 4, 4, 1. This will also not work because it should minimum be 1 of delta, and I don't think it can be same. And let's see the last one. This is 1, 3, 6, 9, 7. So this has a gap of 2, 3, 1, 2. So this one is also safe. So we can see that here we have 2 row reports safe, which is the first one and the last one. And if we compare that here, it seems like we are correct. So in this example, 2 reports are safe. So now our task is to basically look at the input data and then verify if the report is safe or not. So Okay, so let's look at the puzzle input. So we have a page here, and we can see it's pretty big, probably a lot of rows. So let's talk about the approach to solve it. It seems like a fairly simple way, right? And I think I'm going to give you a hint. So if you want to pause the video and think how you want to solve it, feel free to do that. But it seems like we can basically validate each of these reports independently. So they don't have any correlation for now between themselves. And when we are validating each row, so basically each row we can put this probably as a list. And when we are validating, we need to check for two things. So very brute force way would be that we can take like a 2-pass approach, where in first pass we check if this is ascending or descending order, and in the second pass we basically check like how is the delta going. But I think since we are checking that and this is like a elimination condition, so as soon as you find that something was increasing and is now decreasing, you eliminate that. So delta probably you won't need to check again and again. And yeah, I think that should work. So we can do it in one pass where we can start to iterate. And once we understand, I think based on the first two the first two elements, we can know like what is the trend, right? So either it is going to be an ascending trend or it is going to be a descending trend. And then as we iterate through each loop, we will first check that if it fulfills the condition of the order that it is following, and whether the delta between the next element and the last element is fulfilling this condition, where it should be either 1, 2, or 3. So let's write some code. We got the 1 star, we followed the same approach and got this done. One interesting caveat here to note, if you are stuck at this before I move to the part 2, is that while calculating the delta, you need to be ensure that you're doing the absolute value. Because if you're only doing it in one direction, it will only work for the cases of ascending. But let's say if you're doing 1 minus, in this case, you're doing 1 minus 3, it will, instead of giving you 2, it will give you minus 2. So take care of that. It took me, I missed that part, and it was like a gotcha when I looked at the question again. But let's move on to the part 2. I will hide this answer and let's make some space here. So let's write here part 2 and let's read it. So here. So now the engineers are surprised by the low number of safe reports until they realize that they forgot to tell you about problem dampener. The problem dampener is a reactor mounted module that lets the reactor safety systems tolerate a single bad level. Interesting. It's like failure tolerance. So basically we can have like a single bad level. And the interesting, so basically this is like a new condition in what would otherwise be a safe report. It's like the bad level never happened. Now the same rules apply as before, except if removing a single level from an unsafe report would make it safe, the report instead counts as safe. So more of the above example in reports are now safe. So let's get that, copy this original text file and get it here, and then now let's try to validate this again using the new one. So we can basically tolerate at least one bad level, right? So looking at this, this anyways was safe before, so I think we should be good. Let's look at that. So again, two conditions. So the condition 1 was it should either be in ascending or descending order. Condition 2 was that your delta between two elements should be between greater than equal to 1, x less than equal to 3. So between 1 to 3, and obviously we are saying this is absolute, right? And now I think the third condition is that like we can tolerate one bad level is fine. So one bad level is okay. So let's look at the other one. So 1 to 2, 2 to 7. So this is one bad level already that is happening here. Oh, we can remove a level. Okay, let's. Interesting. So if we remove this level, it still fails because 2 to 8 is a leap of 6, right? But if we, and this already fails because we cannot. So this won't work. Let's see this. So 9 to 7 is 2, 7 to 6 is 1. And now 6 to 2 is your leap of 4. And 2 to 1 is 1. So now if I remove any level, basically the only level I see that I can remove is this, but if I remove this, the gap becomes even higher, which is 4 plus 1. So it doesn't work. But let's say if this was 4 here, in that case it would have worked because then 6 to 4 would have been a jump of 2. But let's not complicate this. Let's look at the next example. So next example is interesting because it was increasing here, but it started decreasing here, but then this is increasing here. So in this case, there is a gap of 2, and where it fails on this bad level, if I were to remove the 2 part, the leap from 3 to 4 is 1, and then 4 to 5 is 1, which means that now this becomes like a safe report for us. Similarly, looking at 8, 6, 4, 4, 1. So in this case, like 8 to 6 is correct. It's 2. 6 to 4 is 2. This was failing because this was 0. And in this case as well, if I decide to remove the 4, from 4 to 1, the leap is of 3, which if we see here is allowed. So this also becomes safe now. And coming to the last one was safe in last example. So we will mark that as safe, and then this is safe. And as per this condition, our answer now is 4. So which is correct. The 4 problems are actually safe. So now we will just update our code. So initially we had 2 conditions. In this, we'll basically check. This is actually very interesting because there is a bit of backtracking going on. But one thing by dry running this code, I can see very well is that I think you still check for the ascending order first, and if the ascending order doesn't work and if it returns you like an error, so there are multiple paths, right? So if I look at the condition 1 and 2, so if condition 1 is like checking ordering, so in this scenario you have 2 options. So either it is true or it is false. And if I make some more space for me here, basically ordering is the ascending and descending one. And even if this is true, then you have the second level, which you check for the delta between the levels. And in this case also you will get 2 options, like it's either going to be true or it's going to be false. But now, because we have, even if the ordering is incorrect, we have to validate for that. In this case, when it goes bad, we can check for the third condition here, which is like by removing 1 level and seeing that if we remove 1 level, does it allow us to go into this loop? And if it goes into this loop, then it obviously comes back. And if you have not been through this loop, so we have to basically check if it is modified or not, and it goes false, I think we can again try to basically remove a level and then see what happens. But this can only happen once. So we have to take care of that. So now that we have this, we can go ahead and write some code. And what I'm thinking is I'm thinking of following it exactly like the tree that it helps visualize it, right? Like I would like to like the code in a similar way. So with basically like a little bit of backtracking, and when we are removing 1 level, it is going to create like multiple cases like that. So let's do that. And welcome back. As discussed, we were able to basically solve the problem. We got another gold star. We have now 4 stars. I use the same approach to solve it. I think I just made one modification. So remember during the part 1 discussion, I said that we can basically do a one pass. So again, this is like a hint for you. So the simple idea is that you had an initial function called isSafe in a way that takes like a report, and it does like two checks for you. Like it does like your order check, like if your report is ordered or not, and the second one is it checks the delta. So now in this case, since you can have a failure tolerance of one level where you can basically remove any of these one levels and then try to check if this is safe or not, like in these two cases that we discuss, you can imagine writing some code where you basically call this function, and if it returns true, you're good. But if it returns false, all you need to do is you need to basically remove one element from that report. So basically, if it is A, B, C, D, all you need to do is you need to basically remove one function, call this. If it works, it goes to true, all good. Else, you try again, you remove this, and you again call that, and so on. And I think this is more than enough hint for you to solve the problem. If you are still struggling and are not able to solve it, please look into my GitHub repository. I have written the code, it's bare bones, but before committing, I will make sure to add some comments to explain how it works. It's very elegant. You will probably enjoy reading that. And yeah, that's all. As always, any comments or any feedbacks are appreciated, and I will see you in the next one. Take care.